Good afternoon, students. In our last lecture, we have talked of sympathetic and parasympathetic system, the basics of them. Today we are going to deal with adrenergic agonist and antagonist. We know that the catecholamines, they are synthesized from tyrosine, and from tyrosine what we get is dopa with the help of tyrosine hydroxylase enzyme. From dopa we get dopamine, and then dopamine is converted to norepinephrine with the help of dopaminergic beta hydroxylase enzyme. This norepinephrine is then converted to epinephrine with the help of enzymes. These adrenergic neurons, they release neurotransmitter noradrenaline, which goes and acts on the receptor which are present on the effector organ. After the action is over, norepinephrine is metabolized by two enzymes, monoamine oxidase enzyme and catechol O-methyl transferase enzyme. Now, to produce the action of adrenaline, noradrenaline or any of the catecholamines, these catecholamines have to go and act on the receptors. These receptors, they are present on the effector organ, and these catecholamines, they are stored in the form of vesicles in the neurons. Whenever there is an action potential, these action potential causes the release of the neurotransmitter from the vesicles. The vesicles, they go and bind to the surface of the neurons and release the catecholamines in the synaptic cleft, where they go and then act on the receptor present on the effector organs. Now, let's talk about the receptors, the most important thing. These adrenergic receptors, they are classified as alpha and beta adrenergic receptors. Alpha adrenergic receptors are mainly of two kinds, alpha 1 and alpha 2. The beta adrenergic receptors are beta 1, beta 2 and beta 3. It is because of this difference in the receptors, the drugs, they produce different action because they act on these receptors to produce their actions. Now again, these alpha 1 receptors, they are subclassified as alpha 1A, 1B and 1D. The alpha 2 receptors, they are alpha 2A, alpha 2B and alpha 2C. Beta 1, as already mentioned, are beta 1, beta 2 and beta 3. Now, let us talk of the alpha 1 receptors. Alpha 1 receptors, they are present on the blood vessels. When any catecholamine goes and binds to the alpha 1 receptor, for example, when we talk of noradrenaline or adrenaline, when it goes and acts on the blood vessels and binds to the alpha 1 receptors on the blood vessels, it causes contraction of the blood vessels. When they act on the splenic capsule, it causes contraction of the splenic capsule. On the glands, when these catecholamines go and act on the gland, they cause secretion. On the gut, they cause relaxation of the gut. On the liver, they cause glycogenolysis, and in the eye, they cause mydriasis. To produce all this action, adrenaline or noradrenaline, they have to go and bind to these receptors and produce their action. The alpha 2 receptors, they are present prejunctionally on the neurons. They are also present in the pancreas, where they cause decreased release of insulin, and they are also responsible for platelet aggregation. Now, these beta receptors, they are present on beta 1, beta 2 and beta 3. The beta 1 receptors, they are present on the heart. Keep it into mind that on heart we have beta 1 receptors, whereas alpha receptors, they are not present on the heart. Beta 1 receptors, they are present on the heart and they have an inotropic effect. The beta 1 receptors, they are also present in the kidney and they are responsible for the release of renin from the kidney. Beta 2 receptors, they are present on the smooth muscles, on the liver and also in the eye. Beta 3 receptors, they are present on the fatty cells and they are responsible for lipolysis. Now, in our next lecture, we are going to talk about classification of the receptors, how they are classified as natural and synthetic, and according to their even the mechanisms. Right? We are also going to talk about the pharmacological action, and for this I want you to go through a video which I'll send you in the form of a link on your email addresses. Thank you for patient listening.